we're given a graph and we're asked to graph the polynomial functions f of x using the graph. The first thing I like to do is to look at the directions of my arrows. Okay. They're pointing towards the same directions, so I know that my leading coefficient is going to be, my degree is going to be even. Okay. And since it's approaching all of these positive y values, then my leading coefficient is going to be negative, right? Okay. So that gives me an idea what's my polynomial functions formula is going to look like once I constructed it. Okay. First thing to do is you have to list down your zeros. Okay. So your zeros is where the graph crosses the x axis. In this case, it's -4, -2, 1, and 3. Okay. So I'm going to go ahead and write that out. We have 4 x values. Okay. So x equals -4, x equals -2, 1, and 3. Okay. The next thing is actually determines your multiplicity for 4 of your x values. Okay. So at x equals -4, you want to zoom in a bit. Okay. And you can see that it crosses -4 linearly, right? It just goes straight through. So you know that your leading degree is going to be 1. It's going to be an odd because it crosses, and it's going to be 1 because the graph crosses -4 linearly. Okay. 1. At -2, if you were to zoom in, the graph crosses -2. So that means you're going to have an odd multiplicity. But in this case, it crosses, but it kind of flattens out at -2, but it still crosses -2, just not linearly. So your degree is going to be 3. Right? 3 is an odd degree. At 1, same thing, and at 3, same thing. The graph crosses 1 and 3 linearly. Your leading multiplicity is 1. Right? Your multiplicity would be even if you have a graph and okay, but then let's say somewhere here, right? You can see that the graph did not cross. It bounces off at some x values here. Okay, your multiplicity there would be a 2. It would be an even multiplicity, but in this scenario, we don't have that. For this graph, we don't have that. Okay. So now we're going to go ahead and construct the polynomial functions for f of x with using our zeros. So first you want to write out fx equals, remember, we did not determine what is our leading coefficients is. All we have is our zeros, so we need to find our leading coefficients. So you want to go ahead and put, A could be C, D, whatever. You want to put something there, so then you can find your leading coefficients later on. Okay. And now you want to list down the factors of all of your zeros. So whatever you have, you want to actually take the opposite of that. Here we have x equals -4. Then you want to take the opposite of -4, which is x plus 4. So x plus 4 is the factors of x equals -4. Same thing here, x minus 2, you want to go ahead and do x plus 2. Right? X equals 1, you want to go ahead and do x minus 1, opposite. Okay. X equals 3, you want to go ahead and do x minus 3. The reason why is that if you were to set it up, let's say you were to set it up something, x minus 3 equals 0, right? And then you plus 3 on both sides. That means the factor of x equals 3 is x minus 3. go ahead and erase that. Okay. So now you have to find your a. Then this polynomial functions will be complete once you find your a. You don't want to use your x-intercepts. Right? The reason why is that if you were to have an x-intercepts, okay, right? That means you're going to have some x values. It could be 0, it could be -1, 3. Right? It could vary. It depends on what your graph is. Okay. Comma. Your y is always going to be 0 because it's your x-intercepts, right? So then you would have 0 equals a. Okay. And then let's say if your x, right? Let's say your x is 1. Right? You have 1, okay, plus 4. Okay. And then 1 plus 2, but you get the idea. So then you would have 0 equals a. Okay. And then you would have some number here. Okay. Let's call it x. You're going to go ahead and divide that number by x. Okay. Well, if you do realize that 0 divided by whatever number it is just going to be 0, right? So that is not going to work out. So I'm going to go ahead and clear this for a bit. Let me zoom out. Right? So we don't want to use the x-intercepts for that reasons. But if you look at this graph, they do give us a y-intercept, which is 0, 2. Sorry if it's a little bit hard to see here. It's 0, 2. So I'd rather use my y-intercepts, right? Because my x is going to be 0, and then I don't have to deal with that. With having a value of x that's like really high, and then you got to multiply and subtract a lot. So the point I'm going to use is going to be my y-intercepts. Okay. And then zero, 2. Okay. So you can use any point on the graph, including your y-intercepts, but just not your x-intercepts. Okay. Then I'm going to write down, remember this is your x, this is your y. So 2 equals a. Okay. 0 plus 4. 0 plus 2. Okay. 0 minus 1. And then 0 minus 3. Okay. So the one thing I did forget about is actually writing out your multiplicity, right? So remember to write that out. Sorry, I forgot all about that. But this is how you write it out. So at x equals -4 here, right? Your multiplicity is 1. So all you have to do is to put 1 here. Okay. At x equals -2, your multiplicity is 3. I'm gonna go ahead and put 3 here. Same thing for x equals 1 and 3, multiplicity is 1. You want to go ahead and include that. Okay. All right. So then 1, 3, 1. You don't have to always put down the 1, because any number to the power of 1 is going to be that number. Okay. So 2 equals a. Right. 0 plus 4 give us 4. 0 plus 2, okay, give us 2, but then we have to cube it. 0 minus 1 is -1, and 0 minus 3 is -3. All right. Then we have for 2 equals a. 4 times, okay. 2 times 2 times 2, that is 8. Okay. -1 and -3. 2 equals 8. 4 times 8, it says 32, times -1 is -32, times -3 is positive 96. So it's positive 96. Now we go ahead and divide it by 96, divided by 96. And it looks like it could be divided by 2. So we're going to go ahead and divide by 2, which is going to give us, let's see, which is going to give us 1 over 48. Right? That's our A. So you want to go ahead and rewrite your formula including the A. So it looks like I'm out of space, so I'm going to go ahead and write it down here. Okay. You would have f of x equals 1 over 48. Okay, and you're going to go ahead and rewrite all of these. Okay. X plus 4. X plus 2 cube. Okay. Remember the cube. X minus 1. Okay. And x minus 3. So this is your formula right here for these polynomial functions for this graph, right? So next is that we want to determine our long run behaviors, right? What is our long run behaviors? So to look at the long run behavior, you would have to look at the y values and all of the x. So you can see here that the graph is just keeps on approaching up and up, right? So there's never going to be a point where the graph approaches negative y values. So all of your y's value keeps continue to be positive. Right? If the graph, right, keeps on approaching up and it keeps on stretching out, so that means it keeps on going, all of the x keeps on going towards the opposite way, keeps on stretching out and stretching out. Right? You would have all of the x values here, right, and all of the x values here. Okay, so that means if your x, let me go ahead and write that out. Right? If x approaches negative infinity, okay, which is on this side, you can see if x keeps on approaching negative infinity, all of your y values is going to be positive. If you want a comma, then f of x approaches positive infinity. Okay. If x approaches negative infinity, which is going out this way, all of your y values is still going to be positive infinities. Right? Right? So x, if approaching positive infinity, f of x keeps on approaching positive infinity. So these are your long run behaviors. Right? So that's how you determine your long run behaviors and construct your polynomial functions using a graph.